section of this unit. This is probably not a typical unit some people do. I kind of made it up, but it's something that does pop up on the state test, which obviously is not an issue right now. But so since it's on there, I have to teach it to you. Like always, let's go ahead and do that warm up real quick. So you have two sets of parentheses and multiplying, so that's where you're going to do the FOIL method. So you're going to take 2x squared to x, which gets you 2x cubed, and then the 2x to the 4, which gets you 4x squared, and then the 3x gets you 3x, and the 3 and the 4 get you 12. If you notice, nothing collects, so these are gone right away because it has 2 terms, it has 3 terms. We have 4 terms. And did we make a mistake? Oh, dude, I made a mistake. Right here, 2 and 4 would get you 8, so that is the answer. Oops. All right, let's get into this. All right, so linear, exponential, and quadratic. These are the 3 functions we have learned this year, and that is the main focus of Algebra 1. Okay, so just some obvious. Linear makes a straight line. Okay, that's the first thing we graphed. Remember, things we talked about for this is, it has a y-intercept, and then we find the slope, and slope is like rise over run, or y2 minus y1 divided by x2 minus x1. Okay, so there's some things that we talked about. Exponential, now this one right here is the decay, just to keep that in mind. It's going to grow really quickly or fall really quickly, so decay, and it kind of then flattens out. So if you notice, it flattens out, and that's because of that asymptote we talked about. And quadratic is that parabola. So if you know the vertex, you have things that are symmetric to each other. So those are just some little characteristics we can talk about. But how do we figure out if something's linear, exponential, or quadratic by just looking at the table? So when it says first difference, it means you're trying to find like literally the difference that you're subtracting. So the y values and the x values change on the same slope, okay? The y values on exponential are going to go really, really fast, and you're going to notice a common ratio, and we talked about that. That's basically saying that it's, oops, what did I do? It's basically multiplying, okay, something, instead of there being a difference. So it's multiplying. I want to say multiplying with quotations because it could be like a fraction. It never divides, it always multiplies, but either multiplies by a whole number or a fraction. So a rational number. Okay? You're never going to see the same y value twice. Where you would see the same y value would be in quadratics. I changed up the color and I can't do that. I can't do that. And that's because it mirrors itself right here on that vertex, and that's really bad. And the kind of weird thing, and I'm going to highlight this totally different colors, the second difference are the same. So if you find the difference between 2 values and then do that again with 2 other values, and those are the same throughout the entire table, then it is a quadratic. So kind of split off number 2. I'm doing example 1. I'm going to stop the video and then do the second page. So I'm going to make this as 2 parts. Okay, so using this table right here, please note, first off, that you're going by ones on this, and that's important to know right here that you're going up by ones. Okay, so that's consistent. So then we have to find the differences. That would be my first step. Find the difference between each value, if you can find one. So 3, 3, and 3, okay? I want to write this down before I say it. Okay. The second question you would ask yourself if there wasn't a common, like a difference, and you notice like 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3, we have our answer, okay? But if you didn't have that, then the next step would be common ratio. And then the next step would be the second difference. So that's kind of what we're going to follow to do this. So you notice that right here, the points are going up by 3s, okay? So it goes up 3, goes up 3, goes up 3. It goes up 1 consistently. So this is what it's saying. It's basically saying it has a slope of 3. Okay? And only thing that's going to have a slope is a linear function. Okay? In the next video, I will give you like a more visual representation of these, but this is just the first example. So go ahead and go to the next video. It should be in the upper left-hand corner, and continue with these notes. Awesome.